the honor of introducing one of the pioneers of the internet, Vint Cerf.
There we go. I had to unmute myself. So Jason, it's really great to see you. Thanks so much for those thoughtful remarks. And I share your congratulations with all the students who have competed and contributed to this year's activity. This congratulations goes not only to winners, but to everyone, because engaging in this process is always a learning opportunity. You mentioned that you were working with a friend, another student, at the beginning of your career in computing, and I can say the same thing. My best friend in high school and I got access to some computers at UCLA in 1960. I know that sounds like it was sort of pre-Civil War or something, but we stayed together, working together for literally the rest of our lives. So we're still close friends. We still work together. We were both part of the early development of the ARPANET, the predecessor to the internet. And I have to say, the picture of the Apple II Plus resonated very strongly with me because I remember buying one around 1979. It had VisiCalc running on it, which is an automated spreadsheet system. And I had experienced spreadsheets in paper form that took a week and you could easily make mistakes. The real-time stuff that VisiCalc offered really made a huge difference. You could experiment with parametric changes, in a sense, literally like getting to try out different possible futures. And so it was a tremendous positive experience for me. The thing I would point out, however, is that working together really makes a huge difference in bouncing ideas back and forth. So my early involvement in networking came when I was still a graduate student at UCLA. And my focus of attention there was on the ARPANET design. And my best friend, Steve Crocker, led the network working group that did the early protocols for the ARPANET. One was called NCP, for Network Control Protocol. That experience, which was enormously successful, was funded by the Defense Department. And the reason the Defense Department was funding this network is because they were paying for research at a dozen universities in artificial intelligence and computer science back in the mid to late 1960s. And everybody kept saying, you have to buy us a new world-class computer in order for us to do world-class research. And everybody, the government, in particular DARPA, said, we can't afford to buy a dozen brand new world-class computers every year for each of you. So we're going to build a network and you have to share. And everybody hated that idea, but DARPA basically said, we're going to do that. And oh, by the way, we'll fund all of you. So don't hide your ideas in order to be competitive for next year's proposals. Share what you've done so we can advance the state of the art as quickly as possible. So this collaborative tool, this network, demonstrated the wonderful power of working together across the network. That led the Defense Department to say, well, if we can use computers for that, maybe we can use them for command and control. That led to the realization that some of those computers would have to be in ships at sea, some would have to be in airplanes, and some would be in mobile vehicles. And you couldn't use dedicated telephone lines, which is what we built the ARPANET from, to connect the vehicles together. The tanks run over the wires and they break and the ships get all tangled up. The airplanes never make it off the tarmac. So we had packet radio, mobile packet radio, and packet satellite in addition to the ARPANET to put together. So when Bob Kahn and I got together when I was at Stanford as a faculty member in 1973, that was our problem. How do we connect these different nets together in a uniform way? That was the internet problem. And we essentially solved it in about 6 months, developed a protocol called TCP, and then began detailed specification and implementation starting around 1975, which is quite a long time ago. So that all worked. And the reason it worked in part is that the Defense Department was paying for all of it. Once it was demonstrated that you could link these various networks to each other, the next thing that happened is that others realized, in the government, realized that they wanted to be a part of that growing network environment. So the National Science Foundation designed and built the NSFNet backbone to connect 3,000 universities in the US together. NASA and the Department of Energy had laboratories that needed to be connected together and 2 supercomputing facilities. And so they joined by building their own backbone networks and interconnecting them to form the growing internet. So by the time 1990, well, actually, by the time the Gopher thing rolls around, I was the president of the Internet Society, which we'd started in the beginning of 1992. And somebody drew my attention to Gopher as well. And so I was poking around in it. And the first thing I found in the Gopher system was the CIA World Fact Book. And I went into panic mode thinking, oh God, somebody has put classified stuff up on this public backbone and, we're all going to go to jail. Well, it turned out that was a public resource. And so I was actually much more comfortable after I learned that. We went on, of course, to continue building more internet. It became popular to build pieces around the world in Europe and Asia and so on. Around 1993 or so, no, I'm sorry, at the end of 91, Tim Berners-Lee announced the World Wide Web, and almost nobody noticed. He had built a server and a client using the Next computer that Steve Jobs had built after he was kicked out of Apple. But literally, not too many people saw the World Wide Web idea, except for these two guys, Mark Andreessen and Eric Bina, at the National Center for Supercomputer Applications in Illinois, and they decided to design a browser that had a graphical interface. They called it Mosaic. Well, everybody noticed that because there were millions of downloads. Suddenly, the internet looked like a magazine with formatted text and imagery and eventually streaming audio and video. So a guy named Jim Clark, who had built Silicon Graphics, which was a hardware system to help do computer graphics, saw this Mosaic thing and said, that's a big deal, and brought Eric Bina and Mark Andreessen to the West Coast and started Netscape Communications. So Netscape released the Netscape Navigator in 1994. It was a spectacular success. Suddenly, ordinary mortals could create content and share it around the network, which they did in quantity. In 1995, the company went public. The stock went through the roof. The dot boom was on. And every venture capital company anywhere, but especially in Silicon Valley, was throwing money at anything that looked like it had something to do with the internet. And so lots of people started new companies. They didn't all have business models in mind. They really didn't know how they were going to make money. All they knew was that money was flowing in the form of capital. Well, around April of 2000 comes around, and some companies burn through all their capital and they don't have any revenue and they collapse. So that's lesson number one. Revenue and capital are not the same thing. Capital is finite. Revenue is supposed to keep going. If you have a business model, you should make enough money. Don't spend more money than you have. I'm sure you've been through all that. So now we have the dot bust, but the internet continued to grow. And along comes 2007, and what happens next? Apple comes along with the iPhone. Now, to be fair, Nokia actually had some very smart phones as well, but they didn't have quite the same combination of capability nor the salesmanship of Steve Jobs. So iPhone comes along and it is dramatic because now suddenly you have access to the internet anywhere you can get a signal. And of course, these two technologies were super hypergolic because the mobile allowed you to get access to the internet anywhere you were. And the mobile was super valuable because it got access to all the content of the internet and all the functionality, which led to millions of apps and everything else. So here we are today. And what lessons have we learned? Well, we've discovered that you can do a lot with these technologies. People are sharing information like crazy. And unfortunately, some of it is misinformation and disinformation. We have the social networking that's going on, which is an amplifier of everything. Good stuff and bad stuff. We have phishing, we have malware, we have denial of service attacks. So the lesson we're learning in 2020 is that we have to do something to manage this online environment to reduce the level of harmful behavior and increase the opportunity for beneficial behavior if we don't want to lose this wonderful tool. And right now, that's a big issue because there are countries that are saying, well, we should have internet sovereignty. We should be able to build borders around our countries. We should inhibit people's access to information in country. There are all kinds of issues associated with that. Setting that aside for a moment, for everybody who has participated in this event, the internet is an example of a software enhancing platform because everything you do on the internet is all about software. And that is an endless frontier. You know, there is no end to software except the limitations of your own imagination and ability to write programs. And so for me, internet is this wonderful opportunity to advance that software frontier as far as we can take it. Speaking of taking things far, I realize I'm going to run out of time pretty soon. So let me move you to one other futuristic looking view of the internet. Back in 1998, a team at the Jet Propulsion Laboratory and I started working on an interplanetary extension of the internet. We had just seen the Pathfinder land on Mars in 1997 after the Viking landers had landed in 1976, and then for 20 years, nothing worked, everything crashed or didn't make it. 97, Pathfinder arrives, we're all excited. And so we got together at JPL and we said, what should we be doing 25 years, that will be needed 25 years from now? So we said, well, how about an internet for the solar system? So we started working our way through that, discovered very quickly that TCP/IP didn't work very well with a 20-minute, one-way and 40-minute round trip time to Mars. Flow control doesn't work very well. And then there's this problem of planetary rotation. We don't know how to stop that. And so if there's something on the surface that's trying to talk to you with a link back to the deep space network, and the planet rotates, you can't talk to it till it comes back around the other side. And same is true for some orbiting satellites. So we said, okay, we got a variably delayed and disrupted environment. How do we design a protocol for that? And we put together something called the bundle protocol, which is a delay and disruption tolerant networking example. We have standardized that with the Consultative Committee on Space Data Systems, which is part of the United Nations and involves all the various spacefaring nations of the world. We are running the prototype software on Mars and have been since 2004. When Spirit and Opportunity landed, they were supposed to transmit data back to Earth by a direct link to the Deep Space Network, and the radios overheated. And so they backed off on the duty cycle, and they were only delivering 28 kilobits per second anyway. And so the scientists are all grumpy. And somebody says, well, we have an X-band radio on the rovers, and we have X-band radios on the orbiters that we sent 2 years ago to map the surface of Mars to figure out where the rovers are supposed to go. They're still functional. They have power, they have computing, and they have communications capability. Why don't we reprogram them and make them store and forward relays? So we put the prototype interplanetary software on the rovers and the orbiters. Since 2004, that's how all the data has been coming back. All the subsequent missions to Mars have been using the prototype software. Now we are ready to release the standardized versions of the software in the new missions that are coming up in 2020. So some of you know the Artemis mission in the US is Return to the Moon. There's a Gateway mission that goes along with it. They'll all have the interplanetary bundle protocols on board. So we're really excited about that. And that's where we are today. And I suspect that I'm pretty much out of time, and I should be handing off to Erica, who should be popping up on my screen at any moment now.
Great. Hi, Vint. Thank you so much. I love the insights, and I agree. It's really a limitless frontier. There's so much opportunity. So I'm really excited to see the future and what's next. What will the future bring after the internet? So really excited about that. Thank you so much.
The students who participated in this event are the ones who will bring the future to our doorsteps, and I can hardly wait.
Definitely, I agree. Thank you so much.